Alright, so looking at this particular theorem, the theorem states that a straight line drawn from the center of a circle to the middle point of a chord, which is not a diameter, is at right angle to the chord. You should know these theorems in your head because those are what we are going to be using majorly to answer questions. We are going to be using these theorems to answer questions. So let's see, what do they mean? That a straight line. So definitely if I draw a circle out like this, remember that this is my center. So we are saying that we have a chord, a straight line. This is a chord. So we are saying that a straight line drawn from the center of the, so let's make the center here, from the center of the circle to the what? To the middle point, to the middle point of the chord, which is not a diameter, because this is not a diameter. This is not a diameter here. It's not a diameter. Which is not a diameter, is at right angle to the chord. So let's label this place as A. Let's label this place as our B. Let's call this place point O. So if I draw this one down, we have called this one down. So what is now the theorem about? So let's call this point D. Let's call this point D. That is to say that we can as well show that our ADO, we can as well show that our ADO, which is the angle here, that our ADO is equals to BDO, which is equals to what now? 90 degrees, because that is what the theorem is stating. The statement is saying, its theorem is saying that a straight line which is drawn from the center of a circle to the middle point of a chord, which is not a diameter, is at right angle to the chord. So now with this statement now, we can as well show this, that our ADO is equals to BDO, which is 90 degrees. Don't forget that this line is actually perpendicular to this chord, and that is the corollary statement of the statement. I'm going to come back to it. So now we observe that OA is equals to OB given, because that's the radii there, that's the radii here, that's the radii, that OA is equals to OB. If this line is at the middle, definitely we should know that your AD should be equals to what now? BD. Reason given, that's given there. That means our AD should be equals to what now? BD. So in that case now, it definitely means that we can as well then show from what we have that if that is given, so what happens to a straight line? We know that angle on a straight line is equals to what now? Sum of angle on a straight line is equals to 180. So now with what we have here, we can then as well say that our ADB, we can say that our ADO plus BDO is equals to 180 degrees. And reason, angle on a what? Angle on a what? On a straight line. Angle on a straight line. Angle on a straight line. Angle on a straight line. And we definitely know that since from here we said AD is equals to BD, so we can say that let this one be X plus X. Let's make this one X equals to X. So that's 180 degrees. So we have 2X here is equals to 180 degrees. So what's our value of X now? Our X is equals to what now? 90 degrees. So what can we conclude? We can therefore say that our ADO is equals to BDO, which is equals to what now? 90 degrees. So the statements that we have that says a straight line drawn from the center of a circle to the middle point of a chord, which is not a diameter, is at right angle, is a statement of fact, and has already been proved. We have just shown it on the board. So the perpendicular bisector of any chord passes through the center of the circle. That will lead us to our theorem 2. Our theorem 2 will explain that very well. Let's look at our theorem 2 as the case may be. Theorem 2. So from what we can see here for theorem 2, we are stating that a straight line drawn from the center of a circle perpendicular to a chord bisects the chord. By definition of statement of facts, if I place it as my center, let's draw a straight line drawn from the center of the circle, from the center of the circle is perpendicular to a chord. Let's label this chord A and B, perpendicular to the chord. Bisects the chord. That was the meaning of bisect, divides the chords. So you can see it so it is more or less like a corollary statement, a statement that backs up a theorem, that backs up a mathematical proof. This is what we refer to as a word that backs up a proposition. It's a statement of fact. Is what we call a corollary. So the two of them are actually saying the same thing. But in what? This is just been a rephrased form of this. Definitely we know that in as point is perpendicular, this place should be angle 90 here. So we are saying that a straight line drawn from the center of a circle perpendicular to a chord bisects the chord. And you also know that from our theorem 1, we've clearly stated it out that a straight line drawn from the center of a circle to the middle point of a chord, which is not a diameter, what does it do? Divides the chord, is at a right angle to the chord. And we have proved it. So what now backs up that statement that makes it make more sense is this theorem 2, which is stating the same thing but in another way, that a straight line drawn from the center of the circle is perpendicular to a chord, bisects that particular chord. And that is exactly what this theorem is stating. So let's look at theorem 3 quickly before we solve examples. So like I said, let's look at theorem 3. Theorem 3. That one states that equal chords of a circle are equidistant from the center of the circle. Equal chords of a circle are equidistant from the center of the circle. What is the meaning of equal chords? That means if you have a center here, like I said, if I draw a chord here, if I draw another chord here, let's label this chord A, let's label this one B, let's label this one C, let's label this one D. Like I told you, that the basics of this work is to understand all these meanings. When I say a chord, you should know what a chord looks like. Talk about the diameter, you should know what the diameter is. So now we are saying that equal chords of a circle are equidistant from the center of the circle. So if we have here as our radius, let's connect this with this center. Let's call this one our radius here. We have here as our radius, and we also have this one here as another radius here. Now, this point here, we have another point here. Definitely we should know that from our first theorem that says that a straight line drawn from the center of the circle to the midpoint of a chord is at right angle. So you can see it's been proved here. So now this is another radius here, this is another one here. Definitely, if in as much as this is given, this one here should be equal to this. Let's label this place as point O. I'm going to label here as my M. I will label this one as my N. So definitely, this one here should be equal to this. So by statement of fact, we know that our OB here is equal to OD. That's our what? That's the radii there. That is the radii in this question. Our OB is equal to OD. That's the radii. If our OB is equal to OD, now definitely we should know that our OM should be equal to what? ON. Definitely. We should know that our ON is equal to ON, or MO is equal to NO. Given our MO is equal to NO. Why? It is given. MO is equal to NO. Why? Because it is what? It is given from the question. So what can we now say about OMA or OMB? What can we say about our OMB our OMB. We have just shown that before. So our OMB is equals to OND, which is what now? Which is 90 degree. We've just shown that. Which is equals to 90 degree. That means we are talking about the angle here. That our angle OMB, this angle here, is equals to OND, this angle here. So in that case, we've just shown it there. That's why I said that a straight line that is drawn from the center of the circle is what? Is perpendicular to the chord. Bisect that chord. I said a straight line drawn from the center of the circle perpendicular to a chord. Perpendicular to a chord bisects the chord. And that bisect means is at what? Is at 90 degree. So from what we have stated out here is a very clear indication that we can as well say that our AM or our BM, let's just use that. We can as well say that our B of what? Our BM is equals to half of BA. Our BM is half of BA. Likewise, we can as well say that our DN is also half of DC. Is also half of DC. So BN is equals to half of BA, and as well we have it the other way around, that our DN is also half of DC. So with what I've just shown you here, this is a statement of fact that tells us that equal chords of a circle are equidistant from the center of the circle. What do we mean by equidistance? It means they have the same distance. That's the meaning. That they have the same distance because the chords have the same distance. You can see them from what you are seeing on the board. The chords have the same distance from the center of the circle. And this means this chord length, the length of AB, is the same as the length of what? Of CD, as the case may be, as the question is being referred to. So when you see questions, we need to know these theorems in our heads, and these theorems should not be something you should cram. You should know them because we are not going to be solving them by the theorems. We are going to apply these theorems to our mathematical questions that you will be provided with to solve, as the case may be. So let's see questions now as regards to these first three theorems I have handled. Questions on circle geometry.